Okay, r equals 3 cosine 2 theta. That is a function of theta, correct? So that is f of theta. So r is equal to f of theta. If you have to find the derivative, how do you find the derivative?
You gotta trace it and find third. You gotta find where the line is. Just touch it.
To find the derivative? I mean, if you have to take the derivative of that function, can I do dr over d beta? Yes, it's basic approach. So dr over d beta. That would simply be equal to 3. What is the derivative of cosine? Negative sine 2 theta. Are we done yet? No. Take the derivative of that 2 theta, you get 2. So we will get negative 6 sine 2 theta. Good. Well, even though we have dr over d theta, we do not know how to draw, what Caleb was referring to, the line. For that, we need the equation of the line. How to draw a line in polar system. Using a pen.
Yes. Is it different?
When I say draw a line, I mean to say y equals mx plus b in polar system.
Oh, I can't do that.
You can't do that.
There's no y.
There is no x and y in polar. It's just r and theta. I can find the derivative. Drawing those lines could get tricky. So here, all we are doing is finding the derivative of r, how the radius changes with respect to theta, and second derivative, how it accelerates with respect to theta. The derivative of that is negative 6 cosine 2 theta. Derivative of the inside 2, so negative 12 cosine 2 theta. For 0 to pi over 2, how many loops do you get? Loops and duration. So I'll just leave it over here. That is a picture that I have for the curve. It is not forming a full loop. Reason being, we're stopping at pi over 2. If you go all the way up to 2 pi, it will probably complete and form some sort of loop. Now, as you move along that curve, what do you expect the acceleration to be? Starting point in the far right corner, value is 3. So right here, as you move up, people who are taking physics 1, what should happen to the acceleration? We're all drivers, right? Good drivers, so you should know. Yeah. So what happens to the acceleration?
Decrease.
Acceleration decreases.
Is it derivative of the speed? I would say it increases.
You're climbing up the hill, right? If you don't hit that gas pedal, would you go up? No way, correct? So if you have to drive up the hill, you have to slowly accelerate and go up. And then you make a turn, and as you come down, velocity is going to go up. Agreed? And make another turn. And stop at pi over 2 in this case. If I want to know the point where that turn was made from somewhere from 0 to 3 is the turn, at what point did the turn happen, what would you do? Calculus 1. Huh? Where does the turn happen?
0 origin.
The first turn you are starting at 3, right? 3, 0. That would be the point on the far right corner. And you are going this way, counterclockwise direction. And the first turn that you're making is somewhere over there. I want to know that value. How do you find that value exactly? Because the only way you are going to get the exact answer is by setting the step size really, really small. But if you set the step size really, really small, you'll be sitting here forever trying to graph it using your calculator. There is a way to find that. How?
Trace function.
Trace function. Exact value, it is going to give you the exact value. Do we remember the first derivative test? Calculus 1. Oh, that's a bad line. That is the curve we got, and starts at 3, right here, 0 is over there. And if you keep on moving this way, the turn happens somewhere there, correct? Yes? At that point, one would expect 0. Yes? But is the radius 0 at that point? No. So even though if you find dr over d theta, radius is not 0. What we are trying to say is how the radius changes with respect to the angle. So as you go from here, make that turn and get closer to the axis, the radius is not the same as it traces. Do we agree? Yes? So at what rate is the radius changing as you go from starting point to ending point? That is given by dr over d theta. So is the radius changing at that point? Yes, no, maybe. As you go over here and come this way. As you move along a circle, does the radius change?
No.
No. Okay, we'll stop there. How about that? R equals 4. Yes? What is the derivative of R with respect to theta? Zero. Okay, no matter what angle you pick, the radius does not change with respect to the angle. Do we agree? That is a circle. So that is independent of theta. It's just 0. No matter where, if you have a circle, no matter what point you pick in an angular fashion from 0 to 2 pi, the radius does not change. Is that the case here? The rate at which the radius is changing? Is it a function of theta? Yes or no? Yes. Okay. understood that because later we might use it, but the concept is the same. Take the derivative of the first derivative with respect to theta one more time. Good? Okay. 0 to pi over 2, theta, start with 0, pi over 6, pi over 3, good enough, to pi over 2, okay, pi over 2. If you put pi over 2 in the first derivative, what do you get? Oh, sorry, 0. If you put 0 in the first derivative, 0. Oh, another important one. Pi over 4. Okay, dr over d theta, 0, plug it in there, sine 0, 0, negative 6 times 0, 0. Okay, what about pi over 6?
What about? What about?
Final answers? You're giving me sine pi over 6, but if you put theta equals pi over 6, this would be sine pi over 3, which is square root of 3 over 2, approximately minus 4.8. Approximately.
You were close.
4.9. If you put pi over 4, what would you get? That's easy. Pi over 4, 2 times pi over 4 is pi over 2. What is sine pi over 2?
So negative.
90.
So it's negative.
1. Negative 6 times 1, negative 6. Okay. Put in pi over 3, you get 2 pi over 3, which is sine 2 pi over 3.
Well, the other one was negative 5.12,
Oh, it's 5.1.
or if you want to put 5.2 like this, that will also work.
Okay, approximately. It's fine. Pi over 2.
So that one would also negative 3.
This is pi over 3. Sine 2 pi over 3.
Yeah, I got the same thing as what we would have got for pi over 6. I don't know that.
Oh, never mind.
And then the next one should be 0
You've got the same value.
somehow.
What is sine 2 pi over 3? Sine 120 degrees. Never mind.
So then the next one's 0
Next one, 0.
because it's sine pi, which is 0.
Okay, so what can we say? Well, as I change theta from 0 to pi over 2, seems like the rate of change is negative. It hits negative 0.6, and then negative 5 and heading towards 0. Back to our graph. Let's trace and see what happens. Okay, so that is the picture we have, and I'm going to trace go up. Too fast. Okay. Right there. It's giving me X value, it's giving me Y value. it's giving me theta. It's not giving me r there, but you can see r on the side. We are at 2.7. The radius is negative. So, probably for the previous curve, not this one. 0 or not 0? I over to 0.2. Trace. There is positive, never mind. So theta 0 go to 1. X is 2.708. I get y to the 0.548. Plug it in, square root of x squared plus y squared. That is going to give us the radius. Yes. So if r is equal to square root of x squared plus y squared, we have x to be 2.7, y to be 0.548, approximately 9.25, 8 point something, 2 root 2, and 2 something over there. Good. One direction. Okay. Right there, the radius would be 1.92 plus 1.92 squared plus 0.8139. That's the lower limit. Okay, so previous step right here, x was 2.708, y 0.5489. Went up to 0.4. I ended up getting 1.925, 0.8139 for x and y. What happened to the radius? Did it go up, or will it go up, or will it go down? Or did it go up, or did it go down? Back to the previous step. That step, x is 2.7 approximately, y is 0.5 approximately. That step. What happens to the radius? Did it go up or down? Approximately 3 for x, right? 3 squared is 9. Approximately, let's say 1 for y. 1 squared, 1. 9 plus 1, 10. Square root of 10, it's approximately 3.2 something. Good? It's right there. Wrong direction. So we started at 3. At that step, x is approximately 2, y is approximately 1. Square root of 2 squared is 1 squared. Square root of 5 is square root of 5 bigger than square root of 10? No. So what happened to the radius? Decrease. So got a bit closer. Wrong direction. Moved over. What is happening to the radius? Did it increase? Decrease? Decreased? Okay. Wrong direction. One more time. What happens to the radius? Okay. It is decreasing as we move, like the graph says, or like the derivative is telling us. Over here, you have a bunch of circles. the distance from center to whatever point you have is simply the radius. Do we agree? Okay, so first line, second line, third, fourth. What is happening to the radius? Louder, sorry. Decreasing, right? The radius is decreasing as you change the angle. So that's what we captured here. The radius keeps on decreasing. When it is pi over 4, that's where the maximum decrease happens. The rate at which the radius is changing as you move along theta. Easier way to remember a circle. If you draw a circle, its radius is constant, so no matter what direction you go, the radius will remain the same. So no change, zero change. Good. Here, that is not the case. That distance is longer than that, which is longer than that. So radius clearly is decreasing. So when you take dr over d theta, it tells you how the radius is changing for the curve with respect to theta. It does not give you a tangent. It does not give you a tangent line like we did in calculus 1. But is there a way to find it? Absolutely. Good. And we are going to do that.